organic chemistry, and we're specifically going to look at saponification. And our learning intention is to prepare a sample of soap. So to start, saponification can also be referred to as the base hydrolysis of an ester. And soap consists of long-chained carboxylic acids, which is commonly known as sodium stearate. So fats and oils are used extensively in the manufacturing of soap. And it's usually made using carboxylic acids, which are commonly known as fatty acids, and this is one here, which is glycerol tristearate. So it undergoes saponification to produce sodium stearate, which is our soap, and it goes on to produce glycerol, which is an alcohol. The process of saponification has two main steps. The one here on the left, this is called refluxing. And reflux happens in the first stage of our saponification. And the right-hand diagram here shows the second main stage, which is distillation. So the first step of the production of soap or saponification is to add sunflower oil, sodium hydroxide, ethanol and anti-bumping chips to a pear-shaped flask. It's important to know why we add each of these substances. So to start, we add the sunflower oil because it is a naturally occurring ester. The sodium hydroxide is necessary. The sodium hydroxide is added as it forms something called a lye, which allows the saponification reaction to go to completion. Ethanol is used as a solvent for our lard, and then anti-bumping granules are added to help with the boiling and allow it to take place smoothly. The system is then set up for reflux for about 30 minutes. Reflux is a process where the liquid in your pear-shaped flask is boiled and then is allowed to condense back down into the pear-shaped flask. Reflux is used to help prevent a loss of vapor, and it helps prevent the reaction from drying out. Step 3 then is to set up distillation, and you've met distillation many times before, even in your junior cert, and distillation is a separation technique, and it allows for the removal of our ethanol. The solution is then poured into brine, and brine is basically excess salt dissolved in water. And the soap solution is added to the brine because soap is insoluble in a salt solution, so it will precipitate out. And then step 5 is to suction filter, so that leaves your soap behind in your filter paper, and then the filter paper is left to dry. It's important to mention here that during suction filtration, we wash our soap with salt solution, and it's salt mixed with ice cold water. And the reason we use a salt solution is it removes any excess sodium hydroxide that might be present, and the water that is used is cold to minimize the amount of soap that gets dissolved. So let's look at some sample questions that come up frequently with this experiment. The first one is, why is reflux necessary? And I've mentioned that previously. Refluxing prevents your flask from boiling dry, and it also allows the organic reaction sufficient time to occur. The second question then is, why is the solution poured into brine? And I've mentioned that already. It's because soap does not dissolve in a salt solution, so it will cause it to precipitate out. The next one is, what is the function of the ethanol? And again, I've discussed that. The ethanol acts as a solvent for the oil or the lard. The next question is, what is the function of the anti-bumping granules? They allow for smooth boiling and preventing heat pockets from forming. And finally, why is the soap washed with salt solution at the end of our experiment? So the soap is washed with salt solution at the end of the experiment because any extra sodium hydroxide still present will then be removed. So let's have a look at an exam question on this topic. The question says, a student prepared a sample of soap in the school lab. The experiment was carried out in 4 stages. At stage 1, using a water bath, the student refluxed for approximately 20 minutes 4.45 grams of glycerol tristearate together with excess sodium hydroxide pellets, anti-bumping granules and 30 centimeters cubed of ethanol. The reaction is as shown. It says the apparatus was then cooled and rearranged for stage 2, which is distillation, using a water bath. After distillation, the contents were decanted and washed into a beaker containing brine. Filtration was used in stage 4 to isolate the soap. Then, part A asks us, what is the purpose of refluxing in stage 1? And we know that refluxing occurs to prevent the flask from boiling dry and to allow the organic reactions sufficient time to occur. The second part of part A asks us, name the type of reaction that occurred during this stage. And the type of reaction is saponification, or the base hydrolysis of an ester. Part B then, it says what substance was removed by distillation in stage 2, and the correct answer for that is ethanol. Part C says explain the function of the brine in stage 3, and the brine is used to precipitate the soap. And this happens because soap is insoluble in a salt solution. Part D then says why is it necessary to wash the soap thoroughly in stage 4? And it's washed in stage 4 to remove any remaining sodium hydroxide that is present. The second part of this part D then says how should the student have washed the soap? So it should be washed with an ice cold salt solution. Part E asks us to draw the structure or give the name of the co-product of the reaction, and the co-product of the reaction is glycerol, and glycerol has the structure below. The next part of part E asks us where is the co-product found in the end of the process, and it's found in the filtrate or the brine, whichever name you choose. So to do this, I know that I have 4.45 grams of soap, and what I need to do is I need to divide that by the molecular mass of the glycerol tristearate, and the molecular mass of the glycerol tristearate is 890. So if I do 4.45 divided by 890, that gives me 0.005 moles. Now, if we look at my ratio, the glycerol tristearate is to the sodium stearate is a 1:3 ratio. So therefore it will produce 0.015 moles of our soap. And to finish out then, you must multiply that by the molecular mass of the soap. And the molecular mass of the soap is 306. So I do 0.015, multiply that by 306, and I get that the maximum yield I can produce is 4.59 grams of soap. Part G then says, suggest with reference to its structure how soap, like sodium stearate, can dissolve both in non-polar oils and ionic salts, such as sweat in the skin. And that's got to do with, if we look at its structure. So we can clearly see that there is a non-polar part, and that is C17H35. So that is non-polar. So that will dissolve our oils. And then we do have a polar part, which is COO minus Na plus, which is this little part up here, and that is polar, so that is able to dissolve in our sweat salts. And that is a sample exam question on the preparation of soap. So that's it for this video. Have a read over the learning intention to make sure you understand everything we've gone through.